Ladies and gentlemen, welcome. We're here live at KubeCon, and this is our first global online meetup that is not just global, it's not just online, but we're here live at KubeCon. I am joined by my distinguished colleague, Eamon. Eamon, introduce yourself.
Hey folks, Eamon Bauman, formerly of Rancher Labs, now of course with SUSE, so work as a pre-sales consultant. Very excited to be here at KubeCon and show you all the great live content we have today.
So without further ado, we're going to flip it over and we're going to give Eamon here an opportunity to show us what's next with Harvester, with the 1.1 release that hit yesterday, if I remember correctly?
Yes.
So you go to github.com/harvester/harvester and download the latest release, but we'll talk about that in a moment. So without further ado, Eamon.
Let's do it. Right on. There's our slide. Welcome to Harvester, presented by myself, hosted by, of course, you, Robert.
Thank you.
Next one. There you go.
So we are using Crowdcast. We're back on Crowdcast. We went to go to webinar for a fat minute, but we're back. If you haven't used it, I see people are using the chat. The chat here, let us know where you're from. We'd like to hear from you. So if you feel comfortable, we're here live in Detroit. Tell us where you're from and where you're joining us. If you have a question, please feel free to ask the question in the Ask the Question button down on the bottom. And if you like a question, upvote it, downvote it, let us know. I'll try to get to all of them, but if I can't, I will get to them in the community or on Slack. So without further ado, Eamon, all yours.
Well, thank you very much. Let's go over some of the objectives for the day. We did our introductions. That one's crossed off. We're already finished. Next up, we'll talk about what is Harvester. I'd like to give everybody an experience of what is this Harvester thing we keep talking about. What is this hyperconverged infrastructure that we're using in developing this open source product for? We have a brief Harvester demo. This is a version 1.1 live stream, so I've got two great features today that we're going to go over that are present now in this latest version of Harvester. We'll finish up with some questions and answers, a little brief Q&A there, and I'll wrap up with some next steps for everybody.
I hear you, Simon. We're gonna bring his mic closer to his face.
We'll bump that up. Hopefully that's a little better.
Hopefully that's a little better. We do have a lot of background noise, and we apologize, people, because we are live, and there is a lot of chaos here. I'll get some streaming of what it looks like here at KubeCon, so we do apologize.
Hopefully that's a little bit better for you, so we'll jump in. So what is Harvester? What is this product we keep talking about? Harvester is an open, interoperable, hyperconverged infrastructure solution. There's a lot of words packed into that sentence. Let's break it down a little bit. Open is open source. We're developing this product out in the open. It's meant to be interoperable, so we're going to be able to install Harvester on many different substrates. Hardware platforms, you can install it virtually, whatever you'd like to play around with it. It is a hyper-converged infrastructure solution, so that's the HCI portion of the Harvester HCI name. That means what we're doing is collapsing the ability to run compute, storage, and network all into the same device. So we install Harvester HCI on a hardware platform. It's fully open source. Go ahead and download the binaries and roll that out onto your infrastructure, and you have the ability to deploy virtual machines managed by Kubernetes, inside Kubernetes, rather via KubeVirt and orchestrated by Harvester. It's a modern solution built on cloud-native technology. I just touched on that briefly. Kubernetes is the orchestration platform for that. KubeVirt handles the virtualization, and Longhorn underneath it is where we're going to handle all of the storage for these virtual machines. So we're taking a set of open source technologies, compiling them together here to drive our HCI solution. It's production ready, it's completely turnkey. As I said, we're implementing HCI on bare metal services. It's lightweight and software driven. We don't require any additional hardware, including external SANs. So at the edge, this is especially important, we weren't able to take hardware that has disks mounted in it, has PCIe devices and so on, make that available to virtual machines running within the KubeVirt and Kubernetes cluster. It also has a native integration with Rancher for containerized workloads. So here we're able to deploy the well-known and well-loved Rancher multi-cluster management solution, import the Harvester cluster into that Rancher instance. Now we can manage all those virtual machines and containers and Kubernetes clusters from one single pane of glass. So why would we choose Harvester? We've gotten the what, now the why. For that, we have three main reasons. The first one is we enable users to manage their entire infrastructure environments by utilizing modern technology solutions, including GitOps and cloud-native tooling. Customers should be able to simplify their IT operations and manage virtual machines and containers from within a single console. At the reference to that Rancher implementation that I just spoke about, we can import the Harvester cluster into Rancher, we can manage our Kubernetes clusters and our virtual machines from a single pane of glass. And of course, number 3, empower operators to utilize advanced infrastructure innovation and customization capabilities to help them scale. You can bring your own hardware here, use our fully open source tool to deploy your virtual machines onto it on any platform that you like for your bare metal. You've got Dell hardware, you've got Supermicro hardware, you've got HPE, whatever. Let's roll it out onto that. Let's bring you an open source hyperconverged infrastructure. Let's do a brief demo. Wouldn't be a very live stream without that. So we'll jump into a demo here in a second, but I just want to touch on the 2 things I'm going to demo today. And these are the 2 biggest highlights in the version 1.1 release, which, as Robert mentioned, was cut yesterday. The first thing is VM import. We did a bunch of work to make available the ability to import virtual machines from vSphere, OpenStack, etc. into Harvester. What this means now is if you have existing virtual machines running in, say, vSphere or OpenStack, all you need to do is specify a manifest to import those virtual machines into Harvester, and Harvester will handle the rest. It will go out and reach out to OpenStack, reach out to vSphere, it will turn off the VM, it will take the copy of the image, import it into Harvester, turn it on for you, bing, bang, boom.
So we have a question before we switch over to the demo.
Absolutely.
I want to read it out here. Let me see here. One of our challenges at present using VMware VMs is patching the Windows operating system for 1,200 VMs. How is this handled in Harvester?
I think it's going to be handled in a similar way that you would handle it in vSphere. Mm-hmm. What we do in Harvester is focus only on the orchestration and creation of the VMs, the management of that underlying hypervisor. When it comes to operating system level patches, any existing patch infrastructure or strategy can still be utilized. So if you're using Windows management tools, if you're using something open source, all that stuff should still apply to Windows VMs running on Harvester.
Okay, we have one more question, but let's go to a demo and then we'll come back to that one.
Okay, last thing I want to touch on before we go to the demo, the second feature, PCIe pass-through. So what we're looking at here in Harvester 1.1 is the ability to take PCIe devices that are mounted on the host, pass those into the Harvester VMs. So now all of a sudden we can take GPUs, things you might use for AI and machine learning workloads, pass those through to your virtual machines, bing, bang, boom, you're doing model training and everything you need with that GPU into the virtual machine.
That's awesome.
Very cool stuff. Let's jump into that demo real quick. So I will escape out of my slide deck here. And the first thing we'll talk about is the VM import. In order to do that VM import, what I'm first going to show you is the existence of the virtual machine running inside of OpenStack. So let's copy here and hop into our OpenStack environment. Hopefully my VPN is working at the moment. And bear with me if things access just a little slower than usual. We are running our conference Wi-Fi, so sometimes you see some slowdowns there.
And what is a live event without it going wrong?
No kidding. I don't think I've ever done a live demo that didn't have at least something going on.
I know.
Okay, so we hop into our OpenStack environment.
We're live.
Then let's go to the instances section. When we jump into instances, there, we'll see that we have an OpenStack demo virtual machine running. Let's fire that up right here. Click and start. This is just a basic Ceros image that's running, small virtual machine, only used for our example here. We'll get that up and running. Once that virtual machine starts, in the background, let's go to the terminal and take a look at what we're going to actually use to import this. Let me make my context a little bigger here and take a look at this file. There's 2 manifests. Go ahead.
Can you bring that up? Can you make it just a little bit bigger?
Sure, you bet.
I'm an old man, so it's hard for me to see some of that stuff, but
how's that?
Wonderful. Thank you, sir.
Perfect. So we only have 2 resources we need to concern ourselves with if we're doing an OpenStack import. The first is the OpenStack source. This is how do we attach ourselves to OpenStack. Mm-hmm. Where's the endpoint, where's the region, the credentials, all that stuff. The second is the actual virtual machine import. Let's identify what virtual machine we want to import, how do we want to do the mapping of the networks from source to destination, and where do we want everything to end up. So this is what I'm going to apply into my Harvester instance and what will trigger that VM import. So if we make this terminal a little bit smaller, again, we'll come back and OpenStack says There we go. Our virtual machine is up and running. So I'll hop back to the terminal. We'll exit that file, and then we will run apply OpenStack migration.yaml. Running that in my Harvester instance creates those two resources. There's the OpenStack source, there's the virtual machine import. When that creates, we hop back into Harvester, and we can go to our images section. I'm going to refresh the page here again with the conference Wi-Fi being a little slow. It will take a moment. What's happening in the background is in Harvester, there's an add-ons portion in the configuration where you go and you enable the VM import controller. It isn't turned on by default, so it's something additional you have to do. When you enable that VM import controller, we spin up an extra service that handles all this functionality, that talks to the OpenStack server, that grabs all that information. So what's happening now in the background is since that add-on has been enabled, we are going out and talking to the OpenStack instance, and we're starting to harvest, if you will, that virtual machine. You see, I did that little player's nose.
Fun, weren't you?
I've been dreaming about it since last night. What we will see here in just a moment is the images from OpenStack will start to populate. So you'll see two base disks that are going to come in, the root volume and the additional disk that's mounted in that OpenStack virtual machine. Those will both be harvested and populate here in this images section. The Harvester VM import controller, there you go, you can see those popping in right there.
Nice.
The Harvester VM import controller then will take those images, use them as the mounted disks for the virtual machine, spin up that new instance for us, and then map all of the networks as they were in the source OpenStack instance. So this will take a moment or two to actually complete, but you can see in the progress section over here, I'm sucking in those images from OpenStack, and we'll have a virtual machine coming over very quickly. So we'll give that a minute to complete. I think we get some extra instances, extra maybe API artifacts here since we're taking some time to import. And then once that's complete, I'll show you the virtual machine getting set up. In the meantime, while we're waiting for that to complete, are there any additional questions for the moment I can answer?
We actually do have an additional
Awesome.
question.
Let's do it.
All right. So this is from Alexandru. Do you think Harvester can replace a tier 1 hypervisor feature-wise in a data center, basically replacing vSphere, XCP, NG, or Proxmox?
I think it's getting close, but I also don't think it's necessarily geared towards that strict replacement of the data center hypervisor. I think what we're looking at is a specialized solution meant for the edge or for environments where you really want to take advantage of that hyper-converged infrastructure, where you've got disk on device, you've got device on device, we're going to see PCIe pass through it, and you want to take advantage of all of that stuff collapsed into a single node. It doesn't currently have support for SANs, so we're not going to be able to make, full feature replication of something like what he mentioned, like Zen, KVM, Proxmox, something like that, right? But it's so much more adaptable at the edge because most edge devices don't have access to a SAN, aren't worrying about that kind of traffic. They use the on-device disk, the on-device devices, and so it meets that market area, I think, much better.
So it's more, we're seeing people doing it, and seeing some
Customers use it?
It's being used in that edge data center use case.
Yes.
You might see it in a warehouse or
Yes.
a factory or a restaurant or a store or something,
Yes,
right?
exactly.
That's more the use case that we're seeing with Harvester.
Yeah, I think definitely, let's talk about that store use case for a second. We take a 1 or a 2U rack-mounted server or even a small compact server, drop it in the back of a store, your Targets, your whatever's, Walmart's, who knows. You put it on the back of a store and it's powering point-of-sale systems, it's powering warehousing information and so on. That's the critical use case I think you're seeing with Harvester. There, we've got an example. Our virtual machine has been fired up, so I can grab the console, open in WebVNC, and here's our running instance of the VM that we've imported from OpenStack. Pops up, there we go. We're starting our virtual machine. So you can see, even with conference Wi-Fi taking a few minutes for this to load, that VM import process happened in, 5 minutes, give or take? Very nice, very simple way to import virtual machines. The next portion of our demonstration will be the PCIe pass-through. This is where we have a GPU device running on a Harvester host, and we'd like to make that available to a virtual machine also running on that Harvester system. To do that, let me go to the advanced section here, and we'll go to add-ons. And this is what I talked about earlier, where we would enable that VM import controller. We also would be enabling our PCI devices controller. This functions in much the same way. It gives Harvester the ability to recognize on that base host what PCI devices are present, enumerate them, and then enable that pass-through with KubeVirt to the virtual machine. Now that I have this add-on deployed, let's create a VM and actually do the pass-through. So I'll go to our virtual machine section here and click Create. When I create the VM, again with the Wi-Fi, it'll populate here in just a second. We'll give a name, let's call it KubeCon Demo. And we're going to use a base template here. Actually, I'm sorry, I'm going to use an image. So we'll do 2 CPU, 4 gigs of RAM, and down to the volumes, I will use my Ubuntu image there, 10 gig in size, pretty simple. But now, with that PCI pass-through add-on enabled, we can go to PCIe devices here, and let's add our Tesla GPU there. Now that I've mounted it, I simply need to hit Create, and Harvester takes care of the rest. We'll create that virtual machine based on that Ubuntu Jammy image, and we'll pass through that GPU device. In just a moment, you'll see that the virtual machine has started, and I'll be able to demonstrate us consoling in. We'll do an LSPCI to visualize that pass-through has occurred.
Okay.
What do we have for questions in the moment? Anything?
Not at the moment.
Excellent.
Excellent.
Maybe I'm covering everything very thoroughly.
You are, and you're actually going really fast.
Oh, I'm sorry.
Take a moment and breathe. We're here. I know, I'm nervous too. We're here live at KubeCon. One of the things I want to talk to you, so what are some of the use cases for this PCI pass-through that a company or use this and why it's important?
So I think one of the big use cases that, of course, we've talked about and we see here is the GPU pass-through. Mm-hmm. If we want to take advantage of GPUs to do certain kinds of computation, like AI and ML that I had talked about, or additional analytics workloads, that's a great use case.
Okay.
Another use case you might see is in the telco industry, where you have advanced networking features that need direct access to the network card. In that case, we can take the network interface that's mounted as that PCIe device, pass it through the virtual machine.
Okay.
And now those telco applications can have direct access to that PCIe network card because so many of the telco use cases require advanced packet processing, quicker data pathing, that sort of thing. So I think those are two big use cases that work for that.
Okay. Let's see, where were we at?
Well, we've got our virtual machine up. So I'll hop into WebVNC and we'll get that to show up here. Probably still booting, so we'll see a few Linux booting things here. There we go. Let me log in. Type that in. Ubuntu. Put in the password. And you know what I didn't do? You said I was going too fast. I missed one crucial step of this.
What's that?
I didn't set the default password.
Oh,
so let's destroy this virtual machine real quick. It was quick to set up. It'll be quick to tear down and rebuild. And we're going to build a new virtual machine that actually has that correct pass-through. So let me go back to our PCIe demo pass-through here and copy out that little section of cloud config. Now we can create our new virtual machine. Demo KubeCon, 2 CPU, 4 gigs of RAM. You, of course, can season to taste. Put in that, and go back to our PCIe devices section. Here for PCI, there, we'll click on that GPU. And, before I go crazy, advanced options, let's add in that cloud config snippet. Now, our password will be well known. So we'll create that virtual machine and give it just a second.
Now, while that's going, I have a couple questions that are I can ask. Okay. Does the VM import controller work with any KVM hypervisor, or is it OpenStack specific? It would be really cool to bring up a K8s cluster in Harvester on our existing hypervisor, maybe using Talos or similarly built images using K3s, RKE, or RKE2.
I believe at the current time, support exists for OpenStack and vSphere.
Okay.
I think there are other drivers to come for that. The controller itself is only going to run in Harvester and should only be able to connect to vSphere and OpenStack today.
Okay.
But again, we are going to be introducing other providers for that import process.
Awesome. We have enough time for another one?
I do.
All right. Assuming you have the MS SQL Enterprise Edition and you are using the advanced features of it, such as clustering 2 SQL VMs, is it possible in the Harvester, since the VM is inside is KubeVirt?
I believe it should be.
Okay. I think it's something we might have to test out.
I think so. I think it would be testable. Don't take my word as gospel on this by any means, but I think that should be possible.
All right, so we're going to just say that to answer that question, we think it's possible, but we actually think it needs to be tested.
We should test that, yes.
So before we say yes, let us test it, and we'll come back. We'll post it on Slack. We'll post it in the community and let you guys know.
Yes. Let's hop into our virtual machine now that we've actually enabled a password that I can use. We'll get that console back up. There we go. So I'll log in with my super secure password that everybody got to see. Yep. I fat-fingered it. I'm giving you extra time just by making mistakes. All right, so now we can run LSPCI, and we get a whole list of PCIe devices. But let's see if we can find the GPU in that list. LSPCI, grep-i, Tesla. There is our NVIDIA Corporation Tesla T4 GPU.
Nice.
Through into the virtual machine. Pretty cool.
That is pretty cool.
Now, imagine that'll be happening like for those telco use cases too. Doing LSPCI, we're going to have direct access to those network cards. So things like DPD.
And that's all you had to do. That's literally all you had to do. Is
That's
just,
it.
That's easy. Wow.
That's what we aim for.
I'm impressed. I didn't know it was that easy. Now, and to be fair, Eamon has gotten early access to what this is going to look like. I haven't, so this is surprising me, folks.
Sure.
All right, we got a real quick question here.
Yes.
Can we create a node groups to isolate it from the overall cluster for regional grouping or dedicated workloads?
Yes. So there are, if I understand the question correctly, Harvester does have, I believe, the ability to do VM affinity rules through labeling on the nodes themselves. So we can apply scheduling labels and make decisions in Harvester as to where virtual machines can be placed.
Okay. Were there any UI changes to Harvester?
We do. We have some additional things that are present here. So now in the advanced section, we added on the add-ons list. We can take a look at those PCI devices that are there, pretty basic stuff. Also, in version 1.1, we've introduced monitoring and logging. So now we have present the deployment of Prometheus and Grafana and our logging operator to collect metrics and performance characteristics from our virtual machines. So I can go in here, give all of this detail to what we should deploy for Prometheus, hit save, roll that out, and now I've got VM monitoring built into my Harvester solution, including Alert Manager and Grafana, so I can track trends over time. I can receive emails if a virtual machine exceeds its CPU usage or its network bandwidth. So all that stuff comes packaged in with the Harvester solution.
That is awesome.
Pretty cool. Same thing with logging here. I can jump in and install Rancher logging, and I can look at the log output from the pods that are running these containers. So if something goes wrong with the underlying KVM or KubeVirt implementation, I can receive that log aggregation sent to any destination of my choosing. Elasticsearch, S3, Splunk, Kafka, whatever you want to do for your log processing pipeline, now built into Harvester.
That's awesome.
We've also had some more enhancements in our dashboards area. So we click into the dashboards. We used to have pretty basic information here, how much CPU is being used, how much memory, etc. Now we've got more cluster metrics being displayed on this dashboard here. So here's a list of the CPU utilization, the load details, etc. from our cluster, or we can get VM specific. So let's click on VM metrics. It'll take a second to load again on Wi-Fi, but we'll see performance characteristics, I believe, of the individual virtual machines in my Harvester instance. Awesome.
So as it's taking a moment to load, you guys can go out to github.com/harvester/harvester. You can click on the releases. You'll see the 1.1 release. Download, install it. Let us know what you think. It is hot off the presses. It hit yesterday. If you do find a bug, you can go to Harvester, the GitHub page, log the bug there, check it, see if it exists first. I always recommend that one because people forget that. And then from there, you can provide some feedback.
Exactly.
All right. So Simon, thank you for posting that. You want to post our final slide there?
Sure, absolutely. We'll hop back into our presentation here if I understand how to use a computer. There we go. Let that load for a second. Here's our demo highlights, wrap up. There's our next steps.
There it is. All right, so I just talked about downloading, installing, and trying Harvester. Give us a star on GitHub. If you like the project, that's like currency for us. We love the stars, so please do that. You can join our Slack channel. It's slack.rancher.io or slack.rancher.com. One of the two will take you there. You can join us in the community at community.suse.com. You can follow Eamon at Twitter.
Yes, absolutely. Very active on Twitter. At EamonB. There's my handle.
There you go. And I know everybody here follows me on Twitter. I'm at Robert Surt. We'll switch it over to our final. We'll wrap it up. Ladies and gentlemen, thank you very much. Eamon, thank you for coming on and doing this live show in the middle of this chaos we like to call KubeCon. We'll see everybody else in the community. Thank you.
Thank you.